Good morning, students. Welcome to Blue Star Higher Secondary School. Today we are going to see capacitors. Very important one. Capacitor means storing charges. Okay, what is capacitor? When voltage is applied, it converts a charge. When voltage is applied, it converts a charge. Actually, capacitors are widely used in many electronic circuits. You know that. Okay, consider this is one capacitor connected with one voltage. See, this is capacitor, this is voltage. Okay, so when we connect positive charge here, positive charge is created, here negative charge is created. If charge stored in a capacitor is Q, okay, here charge is stored in a capacitor is Q, which is directly proportional to the voltage V. So how we write the equation form? Q is directly proportional to V. Charge stored in a capacitor is directly proportional to voltage. Okay, here Q is equal to, cancel the proportionality, one constant that is called CV. Okay, where C is called constant of proportionality. Okay, therefore C equal to Q by V. So now we can write, this is the unit of coulomb, this is voltage or volts, so it can be written as the unit is farad. Understand? This is very important relation, C equal to Q by V. Got it? Now we are going to calculate capacitance of a capacitor. Okay, here see, two plates are there. When electric field is applied, so plus Q charge is created, here minus Q charge is created in a separation of distance D. Okay, so voltage is applied to the surface of area of plate A. This, it can be A. Okay, here charge is stored in, that is plus Q and plus in this plate, and separated by a negative is created here and separated by a distance is D. So we know that the capacitance equation, C equal to Q by V. What is charge stored in the capacitor is 1 volt. So charge stored in 1 volt called capacitance. Okay, charge stored in 1 volt called capacitance. Now using the physical parameters, area, distance and electric field, we defined electric field E equal to V by D. So V is voltage, D is a distance. So what is electric field? Electric field means it is called voltage gradient. We already know that voltage gradient. If two plates, the voltage is V, if charge density is, we consider charge density, we take sigma. What is the electric field is created? We already derived the equation, that is E equal to sigma by epsilon naught. So I am taking this is equation number 1 and equation number 2. Okay, this is equation number 2, this is equation number 3. So equating this 2 and 3, so V by D equal to sigma by epsilon naught. Okay, that for V equal to sigma D by epsilon naught. Okay, we know that charge Q equal to sigma into A. A is area, this is charge density. So therefore capacitance of the capacitor, so we can write C equal to Q by V. So I am going to substitute what the value of Q. Q is sigma A by what is V? We already derived sigma D divided by epsilon naught. Sigma sigma cancel. Therefore C equal to this epsilon going to numerator, epsilon naught A divided by D. This is called capacitance of a capacitor. Okay, this is for air or vacuum in between the capacitor. So in between this capacitor there is some air or vacuum. So it gives this equation. Suppose any dielectric material is placed in between these two plates, we will get capacitance of capacitor C equal to epsilon R epsilon naught A divided by D. Here epsilon R equal to relative permittivity. Understand? The next topic is energy stored in the capacitor. Capacitor not only stored charges, it also stored energies. Suppose when we connect a battery to a capacitor, the charges are transferred one plate to another plate. You know that when charges are converted this one plate to another plate. Okay, like this. So what happened? There is some work is done by the battery. When we connected with the battery, there is some work must be done by the battery. The work done is stored as electrostatic potential energy in capacitor. This work done is stored as electrostatic potential energy. Electrostatic potential energy. Okay, so consider the charge dq for a potential difference V. The work done is given by we can write dW equal to V dq. I am taking this equation number 1. We know that V equal to Q by C. So I am taking this is equation number 2. So in order to calculate work done, I am going to integrate this equation. Therefore integral dW equal to integral 0 to q v dq. Okay, integral dw equal to w. 0 to q, I am going to substitute the value of v here. So q by c dq. Okay, taking this common term, 1 by c, 0 to q dq. This is w. Okay, so after integrating we will get q squared by 2 this c. So applying the limits, upper limit and lower limit. Okay, this work done is stored as a electrostatic potential energy. What is that? Electrostatic potential energy we given by UE in the capacitor. So UE equal to q square divided by 2c. So work done must be stored as a electrostatic potential energy. We know that q equal to cv. So I am going to substitute here UE equal to, so c square v square divided by 2c. So when c is cancelled, therefore UE equal to half c v square. Okay, also the capacitance of a capacitor C equal to epsilon naught A divided by D. Here voltage V equal to, what is that? Field into distance, that is V equal to E into D. Okay, so alright, UE equal to, I am going to substitute the values of epsilon naught A divided by D into, so instead of the value of V, E D whole square. Okay, so UE equal to half epsilon naught A D into E D whole square. So that is half epsilon naught A divided by D E square D square. So dd cancel. So half epsilon naught A this D into E square. This is UE. Here area and distance we considered as volume of the space. Here A and D are volume of the space between the capacitor plates. Okay, so therefore UE equal to half epsilon naught, this should be written as V into E. So this is volume, not voltage. Okay, so the energy stored per unit volume of space is given by, that is UE divided by volume. That is I am going to write half epsilon naught, here volume is cancelled, we are getting E. Okay, E square. So energy stored per unit volume of space is UU divided by volume of epsilon naught. This volume is cancelled here, so E square. That is, I am taking this is UE equal to what is this, half epsilon naught E square. Okay, so therefore UE equal to capital UE by V. Since, so finally we will get the energy density is defined as the energy stored per unit volume of space. This energy density UE equal to half epsilon naught E square. Okay, next we are going to see effect of dielectrics in capacitors. When the capacitor is disconnected from the battery, okay, consider a capacitor with two parallel plates. See these two parallel plates having area of cross section is A and separated by a distance is D. The capacitor is charged by battery. So see, this is battery, this voltage is V0 and the charge stored in the capacitor is Q0. Therefore the capacitance of a capacitor is given by, without dielectrics, the capacitance of a capacitor without dielectrics, we can write C0 equal to Q0 by V0. This is equation number 1. Now we disconnect this battery from this capacitor and some dielectric material, this dielectric material is inserted in between these two plates. Okay, now we insert the dielectrics between these plates. The electric field is decreases, so the electric field can be modified by we can write the electric field, modified electric field E is equal to E0 by epsilon r. So what is epsilon r? The permeability of this one material, okay, dielectric material. Okay, so here epsilon naught E0 is electric field inside the capacitor when there is no dielectric material. Here it creates, okay, this is E0. Epsilon r is relative permeability of the dielectrics. Okay, so suppose epsilon r greater than 1, the electric field E is less than epsilon naught. Okay, the result of this conclusion, electrostatic potential difference between the plates, we can write V equal to ED. Okay, it should be reduced. Okay, at the same time the charge Q0 will remain constant. This charge Q0 will remain constant once battery is disconnected. So new potential energy can be created. So the new potential energy potential difference is, we can write V equal to ED, so that is E naught by epsilon naught into D. Okay, we know that V naught equal to E naught to D. Okay, therefore V equal to, so I am going to substitute here V naught by epsilon r. This is equation number 2. Here the capacitance is inversely proportional to potential difference. We already know the relation. The capacitance is inversely proportional to the potential difference. So that means, what is that? That means, you know the relation C equal to Q by V. This is the relation. If C increases, potential difference V is decreases. Okay, C increases, potential is decreases. Therefore, new capacitance is presented. New capacitance in presence of dielectric. So when we inserted dielectric, new capacitance is created, that is called C equal to Q naught by V. Okay, that is we know that V equal to V naught by epsilon r. I am going to substitute, instead of value C equal to Q naught by V, instead of V I am going to substitute the value V naught by epsilon naught, that is C equal to Q naught divided by V naught by epsilon r. Therefore C equal to epsilon r Q naught divided by V naught. Q naught by V naught equal to C naught. Therefore C equal to epsilon r C naught. Okay, this is, since epsilon r is greater than 1, C is greater than C naught. Okay, thus we inserting the dielectric constant epsilon r is increases to the capacitance. Okay, so the capacitance C equal to epsilon naught A divided by D from the capacitance of the capacitor. So I can write C equal to epsilon naught A divided by D, that is equal to epsilon A by D. Since what is that? Epsilon equal to epsilon r epsilon naught. Okay, we know that the energy stored in the capacitor before insertion the dielectric. We know that the energy stored in the capacitor before insertion of dielectrics. What is that? We already know the equation, U naught equal to half Q naught square divided by C naught. After the dielectric is inserted, the charge Q naught remains constant, but the capacitance is increases. but the capacitance is increases. Okay, therefore U equal to half Q naught square divided by C, that is half Q naught square divided by, I am going to write what is C, epsilon r C naught, we already derived here. This half epsilon naught C naught, that is equal to U naught by epsilon r. We already know the equation. I am going to substitute here. Okay, this is for, since epsilon r is greater than 1, we get U is less than U naught. There is decrease in energy because when the dielectric is inserted, the capacitor spends some energy in pulling the dielectric inside. Now, when battery remains connected to the capacitor, that is, when battery of voltage V0 remains constant to the capacitor when the dielectric is inserted into the capacitor. Okay, the potential difference V0 across the plate remains constant. So V0 is remain constant. Okay, so but when dielectric is inserted here, the charge stored in the capacitor is increased by the factor of, you know that the factor epsilon r. Therefore we write Q is equal to epsilon r Q naught. Okay, suppose due to this increasing charge, the capacitance is also increased. So the new capacitance we got, that is the new capacitance C equal to Q by V naught, that is epsilon r Q naught divided by V naught. So epsilon r, this is called C naught, that is C equal to epsilon r C naught. This is equation number 2. The reason for increase in capacitance in this case, when battery remains connected here, see, when battery remains connected is different from when battery is disconnected before introducing the dielectric. So now C naught equal to, we know the relation epsilon naught A divided by D, C equal to epsilon A divided by D. We know that the energy stored in the capacitor before insertion of a dielectric, that is C naught equal to Q naught by V naught, that is Q naught equal to C naught V naught. You know the energy stored in the capacitor before insertion of a dielectric. The energy stored in the capacitor before insertion of a dielectric, we can write what is that, U naught equal to half Q naught square divided by C naught. So I am substituting the value of Q naught here. U naught equal to half C naught square V naught square divided by C naught. This one value cancel. Therefore, we get U naught equal to half C naught V naught square. Okay. Here we are not use this relation U naught equal to half Q naught square divided by C naught, because both charge and capacitance are charged. Okay. After the dielectric is inserted, the capacitance is increased, hence the stored charge also increased. After insertion of dielectrics, the capacitance also increased, stored energy also increased. So we can write stored energy U equal to half C V naught square, that is U equal to half, so epsilon R C naught V naught square. So that means this half C naught V naught square, we call it as U equal to epsilon R U naught. Since epsilon R is greater than 1, U also is greater than U naught. It may be noted here, the voltage between the capacitor V naught is constant. V naught is constant. The electric field between the plates also constant. Therefore, the energy density we can write U equal to half epsilon E naught square, where epsilon is permittivity of dielectric material. Epsilon is permittivity of dielectric material.